Hello, I'm Johnny and this is a video about JWT. I'm doing a series of videos building a microservices platform and when building security of the platform, JWT or JWT for short is a critical concept to understand. So I wanted to make a separate video about that. JWT is an open standard for representing claims securely between two parties. And this site, JWT.io, is an extremely helpful resource for working with that and also to understand it deeply. I think that the best way to approach it is to explain this on an example. So here in the debugger tab, you can see the tool used for debugging JWT tokens. And the token is here on the left. It is composed of three parts separated by dots. These parts are basically JSON encoded with base 64. The first part is the header. It contains encryption data, an algorithm and type of token. The second part is the payload. This is where your information is stored. And here in this simple example, we have payload that are just three entries, and the last part is the signature. So I have an authorization server running in the background on which I've created some information that allows me, well, some initial data that allows me to generate tokens for my realm. I will explain all of that later when it's more relevant. And I want to, okay, let's get a new terminal so that is clear. I want to generate the token by sending a request to the server. It's running on port 8090. I'm sending some authorization data here, like my username and my password. And in the response, I am getting an access token, which I will right now paste into the online debugging tool that will allow me to see what's actually inside, because all of this information is encoded in base 64, but it gets decoded online, and this is not encrypted, this is encoded, this is something different. So the first part is the encryption data, the second part is the payload, and the third part is the signature. Encryption data, you can see it's technical, not relevant right now. Payload is something that gets returned. This is the body of the response. This is my authorization server saying that this token was generated by a user which has this username, by the way, username, and this token has this is the date at which the token was issued, type of token, and so on. So this is my payload, and what is critical and allows for all of the use cases that it is used for is the fact that it cannot be changed without becoming invalid. So this property that the token once issued cannot be modified, it is the critical feature that allows for a very different flow of authentication. Here I have very simplified flows of that show the difference between how session-based authentication works and how token-based authentication works. So session-based authentication is how it used to be done, and this was more relevant for monolithic applications where application server had an authorization module built in, and the way it would work was that the client, which is maybe a browser, maybe a client is sending user and password to the application server, for example, in a login form. And then in the application server, there would be a session created, and this session ID would be returned to the user. So in the next request, user and password would not be sent anymore because the session already exists. And the client only sends the session ID together with the request, most often in a cookie or as a header. and then having received that, the application server is able to identify the user's credentials by retrieving this session from session storage, which could be the memory, which could be an external database, but it was accessible. And for example, with this session cookie, the application server could read that this is a particular user and he has access to the resource that it wants. And then after it is positively verified, the application server returns the secured resource. Token-based authentication works in a different way, because here the authorization server is usually separate from the resource server, and the client is sending its credentials. And once again, this is a very simplified flow. There are multiple ways to do this. I want to just explain the general idea. The client is sending its credentials to the auth server, and the auth server returns the JWT token. The token is signed by the auth server, so it allows the client to, when the client sends the actual requests with this token to the resource server, which is let's say more or less what the application server was in the other example. This resource server gets the token, validates the token, often with connection to the auth server, and then returns if the validation was correct, and it confirms that the client is who he says he is and has permissions to the resource that it requests. After that, the resource server returns the secured resource. Another major feature is that auth server and resource server are separate. So this is what allows for the extremely popular feature, which is you can recognize the login with Google or login with Facebook. This is allowed by the structure of this, because once you get your token from your auth server, which in this case can be a Facebook auth server or Google auth server, you can supply this token to the resource server, and then the resource gets a token that says, without providing your credentials to the resource server, or without having any for a particular application, you can authenticate yourself using the data you provided, most commonly just an email, that is signed by the identity provider, like Google. So the resource server gets a token that is signed. They verify to the identity provider whether the signature is correct. And then after this verification is successful, you can basically grant access to the user that didn't have to create any username and didn't have to create a password. There is no overhead connected to creating and maintaining the user's emails, resetting passwords, and so on. So, and the flow it takes a few seconds. So if you remember our debugger tool, the JWT.io, I will post the link in the video description. You can see that there is a request targeted to the local host, which is the issuer of the token. Here you can see that this is localhost. This is where the issuer is located, and this was taken from the token itself, from the issuer field. There is a request for the public key, first for the information about that, and then for the public key. And this key was retrieved from the authorization server and then used to verify the token's validity. Now that you know what a JWT token is, I will be putting that in practice. Next video will be a solution design for small scale proof of concept on how to connect the resource server and the authorization server in Spring Security 5. So, thank you for watching. If you enjoyed the video, please click like, and if you want to see more, subscribe to my channel. Thank you, bye bye.